We are doing optical instrument, and in optical instrument it means device that magnify the image. Hello, Pratigya.
So she said she'll join in 5 minutes.
Okay, and also you all of you have to write notes on this topic. Optical instrument. Eye is one of the part of our body that can focus the image, and main purpose of the optical instrument is to magnify the image so we can see it clearly. We have convex lens in our body. We have ciliary muscle which is responsible for the uh, change adjustment in the focal length. Image is formed on retina. Near point is the closest distance of distinct vision where we see things clearly, and this is 25 centimeter. We'll use this a lot. And far point, if anytime mentioned, is infinity or normal adjustment. This is also known as normal adjustment. Then we use two angle, one alpha angle with the object and beta angle with the image. Alpha angle with object and beta angle with the image. Alpha angle with normal eye and beta angle with the some instrument. That's why aided eye with some instrument. So image will form mostly on the near point where we can see clearly. Best vision at 25 degrees Celsius. Sorry, what I'm saying, 25 centimeters. If you calculate magnifying power, you want to understand how big image is compared to the real object. So here you will use beta by alpha, and here we use this part beta by alpha. See, example, here you have some height of the object and angle is x. If you change height h dash and angle is y, you can see y angle is greater than x. So it signifies that our image is bigger than object. As simple as that. So angle is correlated with the size, height. So more angle, more size. So indirectly we correlate with the angle. That's why in magnification we are using angle beta by alpha. Okay. Same thing here. Here you have object. Object is placed at this distance and angle is this. Image is placed. You have angle beta. So you know image is bigger. So beta will be also greater. Okay, beta will be also greater. If beta angle is more, your image will be bigger. We already did this. You have to consider whenever we are talking about theta, it is approximately equal to tan theta. Like tan alpha is approximately equal to alpha, or tan beta is approximately equal to beta.
Good morning,
Okay.
sir. Sorry for getting late.
Good morning, Anita. It's okay. So, example, if you take simple microscope and you place object between focus and optical center, you know in this case bigger picture will form, which is virtual erect. Bigger picture, virtual and erect, as you can see here. If you calculate same method, magnification is beta by alpha, and it will be equal to 10 beta by 10 alpha. So you will use two things. Key you will use with the aided eye and unaided eye. When you calculate this, ultimately you get this point. D by UE. D by UE for the UE for the eye. Now the point is key There will be two situations. If image is formed at D, near point, then V value will be equal to minus D because placed on the left hand side. And you are using normal formula of the lens formula 1 by V minus 1 by U is equal to 1 by F. Okay, so U value is minus UE and F is the focal length of the image. By this, if you put the value and multiply with the D, your D by FE will be equal to M minus 1 or M will be equal to 1 plus D by FE at near point when image is formed at D, near point, because you know D value 25 centimeter. Second possibility, if image is formed at infinity, then object must be placed at focus. In that situation, everything will be same, but your image is formed at infinity, minus infinity, and object is placed at focus. So you know UE will be equal to FE. That's why the magnification, which was equal to D by UE, will also equal to D by FE. This is at infinity, also known as normal adjustment. So, based on this, based on this, when we use simple microscope, magnification is equal to beta by alpha or D by UE. Now you have two version of this.
Good
One,
morning, sir.
good morning, Tohina. Least distance of distinct vision, also known as near point, where image is formed at D. So you will have this formula. And second, it if image is formed at infinite, you know V will be equal to infinite. This is also known as normal adjustment. Here, magnification will be equal to D by FE. This is what we did yesterday. Again, write this two time, all of you. Doesn't matter who wrote yesterday, and send in the group, and then we'll proceed. This is so important for the today's compound microscope also.
So we have to write it again.
Yeah. Mm, no, I will quickly revise. Compound microscope have two lens, two convex lens. One is objective, second is eyepiece. Objective is smaller and eyepiece is bigger. Eyepiece form the final image. Next, key image formed by the objective lens is real, inverted, and magnified, which will work as the object for the eyepiece. And eyepiece will form the ultimate final image, which is enlarged, virtual, and inverted. I told you theory as of now. Right? Now I'll tell you uh, in diagram how to draw this. So in this case, first draw the diagram here, small diagram. Okay. So because you know your first image is real, inverted, and enlarged, that's why it should placed beyond the focus. Okay. So this lens is known as objective lens, which is smaller. You should place the object beyond your focus. So, example, you are keeping here. Because if you lie between the focus and lens, then it will form virtual and erect image. But we are making real image like this. right? Then like this. So this is a real object A, B, and height is h naught. Okay. Here FO means the focal length of the objective lens. Focal length of the objective lens. You know, if your object is placed beyond the focus, then your image will be enlarged and it will be again beyond the focal length on the another side. So this is the image formed. As you can see, this is real image in large compared to the object and inverted. Correct. In this case, if you see, this will be your what is this? Object distance. That's why U for the object. And this one will be the VO, which is image distance for the objective lens. Okay. Now you have to make, oh my God, I made mistake. That's okay. I will copy this. We need more space. Huh. So now this image formed by the objective lens will act as object for the second lens, which is known as eyepiece. This was the objective lens. Now you have to make one more image which have bigger aperture like this. Got it? So this lens is, as you can see, is bigger, known as eyepiece. Okay. So when this is serving as object, so what will happen again? Line will fall like this and like this. Okay. I will extend this. Okay. This is the problem. This diagram is wrong because if I draw this, it should go like this. But one we have to draw this again, and that is where even you face problem in the drawing diagram. Not key it is difficult, but it's difficult to adjust on one page properly, especially in astronomical telescope. How many of you faced same issue last year? Bored people were in that.
Yes, sir.
You understood this, but you were not able to complete in one page because it was going out of page.
Yes, sir.
Uh, uh, Jordan.
I always had issues with this.
Okay. So this diagram is easy, but remember now you want to make same inverted image, same side and in large picture. So what will happen? Now it should be placed between the focal length of eyepiece and the eyepiece length. So if you form image like this, then it will go back. If it is going like this, then it will go back. Okay. Okay. So I am extending this. So okay. So what is happening? The ultimate purpose is when you placed object, you formed image which was bigger, but not big enough to observe it clearly. Then we kept one more lens. Now because lens have bigger aperture, then it will form bigger image, and image will form here. That's why you will call it as A double dash B double dash. This is final image. And you can understand your first image was smaller, but second image is way bigger. So purpose of the compound microscope is to understand कि you can form the bigger picture. Got it? Any doubt? So this will be the object distance for the eyepiece. Object distance for the eyepiece. Now tell me, Anvita, if you want to calculate the distance between these two lenses, what will be the distance? Length of the tube. What will be this length of the tube, Anvita?
Not sure, sir.
Jordan?
So will be added like U plus
Hmm.
VO.
Yes. Simple addition of these two. Where image is formed by the first lens and where object is placed for the second lens. If you add both of them, you will get total length. Then, okay. Here, whatever image is formed, you can calculate here by using the beta angle because you are using equipment to see the bigger image. And here you will have your eye. So in eye, you can see all the radiation. Okay. So this is the optical center. So and this is another optical center. That's why order. Okay. In doubt, if this is focal length here Fe, this will be also Fe. Both sides because by convex lens. Any doubt in diagram? Draw diagram once again and send in the group because this diagram for the first time look confusing. All the explanation is based on this only. It was guys. Don't draw art, just draw simple line. Do it like this. Okay? You have a long line here, lens. If you place object beyond this, you will place object, and this will be this. Here you form image A dash B dash. Then you place second. This is objective lens. This is eyepiece. So it plays here and this and this. If you extend this further, here somewhere you got the final image. A double dash, B double dash. Here you should have focal length of the object, and this is the focal length of this. So this is object distance. Then this is VO. This is QE, and this will be VE. If you talk about length, what is the length? V of the object lens and U of the eyepiece. Done. How much time it took? Yes or no, guys? Make it fast. I want only this like rough diagram. Very good. I got one. Person notes. Who is this Chandana? Yes, Anvita.
Sir, I'm unable to zoom out, so you can't see the whole thing, but I've drawn everything.
Okay. Okay. You don't later. Yeah. Yes. सानिया तुमने तो बेचारे के साथ एकदम मोलेस्टेशन ही कर दिया. कहाँ लाइन जा रही थी कहाँ भेज दी.
सर टेढ़ा मेढ़ा हो गया तो
स्पेशली जो सेकंड लाइन है ना जो पैरेलल जाके फिर फोकस के थ्रू जा रही थी वो तो जो टेढ़ी बनाई है ना.
Sir, can you scroll a little bit? Yes.
Jordan, how is your eye? You are
I
making
don't know.
eyelids.
I just drew eyelid.
Eyebrows.
That's yo no. That's how I've been drawing eyes since 10th grade. So even then, I used to draw eyes like this.
Okay, make it fast, guys. Tuhina, Sarah, Marinder. Make it fast.
Sir, can you go back? I'm having trouble with the like I'm taking time for labeling.
Make it fast, fast. See, you don't have board, so no worry. You will get same diagram already. But whenever they will give theory question, so you can visualize ki this thing is will happen. I got
तो
Barinder and Sarah.
मेरा डायग्राम थोड़ा गलत हो चुका है.
कोई बात नहीं. Hmm. Only you are left. So make it fast. We again have to calculate same magnifying power. And you know the formula. Sarah, what is the formula of magnifying power? Beta by
बीट
alpha. And beta will be equal to almost 10 beta. And alpha will be equal to 10 alpha. Right? So this is the main formula which we use in the previous topic also. Second, if you calculate 10 beta here, beta for the image, alpha for the object. If you see beta here, can you see in this case, if you consider this triangle like this, so you know this is the height of the uh, this is the height of the image, height of the image. This is the distance which is which will be equal to UE. Correct? Any doubt? So if you consider this beta, so in this case you will say कि beta will be equal to A dash B dash divided by A dash O. Correct? A dash B dash by A dash O dash, not O dash, equal to. A dash B dash is same thing, and A dash O is equal to UE. Any doubt? A dash O is equal to UE. Then at the same time, we have to calculate magnification, and we know magnification is equal to height of the image divided by height of the object, or equal to V by U. You studied this in the lens, correct? Height of the image by height of the object is equal to V by U. So if this is the situation, what is the height of the image A dash B dash for the object lens, for this lens? Forget about the another one. If you consider only this part, height of the object, height of the image, and you can say we consider VO is positive and UO will be negative, right? So if you take for the objective lens, you will write for objective lens, otherwise you will mix it up. So A dash B dash by AB for object height is equal to, what is V value? V naught, because objective lens. What will be U value? UO, objective lens. And what is AB equal to? AB equal to the height of the object. If you consider all this, then your A dash B dash will be equal to V naught by U naught multiply into AB. And what is your AB value? That's not. Okay. A dash B dash value is equal to V naught U naught multiply by H naught. Why? Because you know object distance, you know object height, you know image formed by that, because this image will be smaller. By utilizing this, you can calculate magnification here. Okay. If you calculate your magnification, what will be 10 alpha value? Sania, what will be 10 alpha value here? What will be 10 alpha value here? We wrote same thing above.
Sir, will it be H naught by L?
D, because this is the distance, na? Or U naught, same thing. I wrote it here. See, this is the height of the object. This is the distance, and here you have alpha. So what will be your 10 alpha value? H naught by D. Make sense?
Yes, sir.
Because ultimately, when image formed in your eye, then it will be formed at the best vision, and best vision is available at D distance. Okay. So I will write here again also to reduce confusion. 10 alpha will be equal to H naught upon D. So you don't need to write here and directly move to the magnification part, because we know magnification is 10 beta by 10 alpha. What is 10 beta value? A dash B dash, and instead of A dash B dash, you can write V naught by U naught into H naught divided by UE. Got it? V naught by U naught multiply by H by U naught. This is 10 beta divided by, what will be the 10 alpha? H naught by D. Understood? H naught will be cancelled out. What will be your magnification? Magnification will be equal to V by UO multiply by denominator of denominator is numerator D by UE. Correct? And what is VO by UO? Normal magnification, magnification of the objective lens. And what is D by UE? Magnification of eyepiece. Done. So in compound microscope, if you want to calculate total magnification, how to calculate? Calculate magnification of objective lens, which is equal to this. This is magnification of the objective lens. And this is the magnification of the eyepiece. Multiply both of them. Any doubt, guys? So, and last time you calculated magnification was equal to D by UE. This was for the eyepiece in the simple microscope. Same formula we are using here. See, look at this. What was the magnification in the simple microscope? D by UE. So here we are using this as eyepiece. That's why D by UE is eyepiece, and V naught by U naught is normally magnification of the objective lens. Any doubt? Again, two case. Case one, when image is formed at T. Case one, when your image is formed at D distance. Okay, least distance of distinct region. In this case, magnification will be equal to what? Tuhina, at D.
Sir, I'm not sure.
What is the normal magnification value in the simple microscope? This one.
Yes, sir.
And overall magnification will be magnification of the objective lens multiply magnification of the eyepiece.
Yes, sir. So I'm not times 1 plus D by FE.
Magnification of the objective lens is this, and magnification of the done.
Yes.
So overall these formula look big, but in reality, if you know simple microscope, how it works, then done. You take it separately. Done. Tanya, if case 2, you have normal adjustment, image at infinity. Normal adjustment if your image is formed at infinity. What will be M naught value, Tanya?
Sir, M naught will be D by FE.
Correct. For objective lens, what is the magnification? V by U for the objective lens. And what will be magnification of eyepiece? D by, tell me guys. Isn't it application of simple microscope in two different cases? Done. Okay. Remember, in this case, your object for the eyepiece will be equal to the focal length of the eyepiece. Got it? Any doubt? Anybody have doubt?
No,
So if you make summary of this compound microscope, you have 3-4 point to revise quickly. First, if you see compound microscope, your magnification will be equal to magnification of objective lens and magnification of eyepiece, because you have two lens. That's why their magnification will be multiplied. At near point, image from that D is the near point or least distance of distinct vision. At near point, you know your magnification will be equal to V naught by U naught, and for eyepiece D by FE. And if you see for normal adjustment, your magnification will be V naught by U naught. Objective lens, it will remain same, D by FE. That correct? This is at infinity. You have above one. It's just I'm writing for the revision. Nothing else. Near point. You have two lens. Eyepiece is larger, bigger, and object lens will be smaller. Any doubt? Write this 3 times. This case 1, case 2 is really, really important. Write it down. Hello. Hello. 3-10 बजे बात करें. ठीक है, बताया ये होगा तो 9-10 बजे आज पकड़ना है. ठीक है, बता दिए और मेरे नंबर भेज दे. ठीक. Make it fast.
I sent.
हाँ. Write twice. You wrote twice. Yeah. This is important for the revision. And now we'll do question from the compound microscope. By then I will write question, so you can solve that part. And you have to write full notes. I will check notes as well in the end of the chapter. do this question. If you are done with the question, formulas, solve question quickly. And with this question, any doubt? You have to do three things because in your formula, you know that in magnification you need V naught by U naught D by FP because normal adjustment. For normal adjustment, image is formed at infinity. So object will be equal to focal length and your magnification is this. So we have U naught in our question. We have D value which is always fixed 25 centimeter. We have FE. We need V naught. We need V naught for the magnification. How to calculate V naught? You have U naught, you have
So
F
first
naught.
we'll find M and then we'll substitute M in the M goes to V naught by U naught, right?
Uh, so you got answer, Anvita?
I'm writing, sir.
Okay. So through this you will get V naught value using the lens formula. Once you will get this, you know you have to calculate length of the microscope and length of the microscope we already did is V naught plus UE. And whenever there is a infinite normal adjustment, your UE is equal to Fe. That's why you have to apply second formula for normal adjustment. Correct? We wrote here same thing. For normal adjustment, UE is equal to
So
Fe.
V naught value is 12.
V naught value will be 6 centimeter. Check this sign. Here you can also write your length of the tube will be V naught plus Fe, because you know UE is equal to Fe.
So V naught value is 6.
V naught value is 6. So 1 by V naught is equal to 1 by F naught minus 1 by plus 1 by U naught. 1 by V naught. What is the focal length? 1. And what is the focal length of U naught? Minus 1 by 2. Minus 1 by 1.2. So this, if you take LCM, will be 12. 12 minus 10. 2 by 12. 1 by 6. So V naught value will be 6 centimeter. Now you can calculate magnification. V naught is 6. U naught is 1.2. D 25. And Fe value is equal to 2.5. So 6 to the 12, 5, 10. So it will be 50. 50, right? And you can calculate L value. What is V naught value? 6. And what is focal length? 2.5. So 8.5. Any doubt? If we are done with it, we can do the last important topic, telescope. And among the telescope, most popular question you get in your NEET exam is astronomical telescope. Astronomical telescope. This is extremely popular topic. 90% of the question in the from the optical instrument you will get from the astronomical telescope. This is also known as refractive telescope. A refraction is happening here. Yeah. What is the use of this astronomical telescope? It is used to observe very heavy body which is placed at infinite. Observe heavy bodies like star or planet. And again here we use two convex lens like compound microscope, but there is a difference. First thing, both are placed coaxially along the same axis, same like compound microscope. Second, here your objective lens will be bigger because it has to collect radiation from the infinite, so size should be bigger. and then it, you talk about the eyepiece near you, it should be smaller. Okay, here you face issue in the drawing diagram. I think you face maximum issue on this only. So to make it easy, first make a line and you oh, first decide the focal length, because you know all the light will focus on the focal length. Example, you take short and you take focal length, this is the focal length of the objective. Okay, so if you now you take aperture, mm, this. So in this case, what will happen? Parallel ray will come like this. All will pass through the focus only. So you can make it here one. This is wrong. It should be like this, because line that pass through the aperture, it should be straight. But now it is going out of the aperture. We have to slightly tilt this. Okay. Remember, you can never make this diagram properly in one page. There is always issue. So first thing, here you know your objective lens is bigger, and in this objective lens your object is placed at infinite. So that's why you are getting parallel rays from object which is placed at infinite. Whenever object is placed at infinite, you know image formed at focus. Image formed at focus. Here you have f not focal length. Focus. Correct? One thing. So this is acting like this. What should I say? This is acting like object for the another piece. So I have to make. I made it even bigger. I should keep small, but it's okay. This is eyepiece, smaller than the objective lens. Now what will happen? Light will fall from this to eyepiece, and it will also fall to this, and it passed through the focus. This is the focal length of the eyepiece. If you take it back, see, even I can't make it properly. That's why I have to adjust this. And your final image is formed here. This is A double dash, B double dash. Okay. Any doubt in diagram? Objective lens big, eyepiece small. Objective lens, object is placed at infinite, so you have parallel rays. Second thing, here you will have angle alpha from the infinite. Same alpha will be this, because infinite you can't measure, but here at least you can see this is image formed at the focal length, so A dash, B dash. This one is the beta angle with the eyepiece, correct? So you have all this thing. Next, because you need to calculate magnification, your 10 alpha will be equal to A dash B dash divided by focal length, and your 10 beta will be equal to A dash B dash divided by what is the distance? It will be UE. See, this is UE, this is focal length. Arey, this is focal length, this is UE. If you want to calculate total length between here to here, you know total length will be equal to focal length plus distance of this. Any doubt? Anybody have doubt? Okay. If you know, for the best revision, image should form at D. So if image is present at D, least distance of distinct region, then you know your image is formed at D minus D. Your U will be minus UE for the eyepiece, and your focal length is for the eyepiece, this focal length. And if you calculate your magnifying power M, this magnifying power is also known as the angular magnification that we have seen in case of previous question M. So this you know M is equal to beta by alpha, approximately equal to 10 beta by 10 alpha, equal to what is your 10 beta? A dash B dash by UE, 10 alpha A dash B dash by F. A dash B dash cancel out with each other. So your final magnification will be equal to focal length by UE. Done. Again, two different cases. Two different cases. First, if you take maximum magnification when final image is formed at D, then you have to do derivation, proper derivation. Case 1, when image is formed at D, near point. You know, in this situation, your lens formula is 1 by focal length is equal to 1 by V minus 1 by U. Focal length for the eyepiece is equal to 1 by V minus D minus U minus UE, correct? So this will be equal to 1 by UE minus 1 by D. If you multiply everything with F naught on both the side, so what will happen? Using same equation, F naught by FE is equal to F naught by UE minus F naught by D. Correct? So what is your F naught by UE magnification. See, f naught by UE is your magnification. So this f naught by UE is your magnification. In that case, can we say f naught by FE magnification minus f naught by D? It will go to another side. Magnification is equal to f naught is common 1 by FE minus 1 by D. Correct? If you take minus or plus, sorry, plus, go to another side. If you take FE common, so f naught by FE will be equal to 1 plus FE by D. Done. See, initially you will feel ki formula, sir, formula are tough. Formula are not tough. You are not supposed to remember every formula. You have to correlate how at near point. That's why you get more questions from this topic, astronomical telescope. And case 2 is very easy. When image is formed at infinity, normal adjustment. When you have image at infinity, normal adjustment. Normal adjustment. And you will use this word distant object, image at infinity. Okay, meaning is exactly same. In this case, you know, you will use same formula. Magnification is equal to f naught by fe 1 plus fe by d. But you know here image is formed at infinity. So your d is equal to infinity in this case. Image is formed at infinity. That's why it will be equal to done. Okay. And you know length of the tube, telescope tube, L is equal to focal length of the objective lens and distance of the image. Done. Final conclusion. If you take summary of this topic, I will make summary of all. First summary of this topic, you know here objective lens is bigger compared to the eyepiece. Second, magnification is equal to f naught by fe. This f naught by fe is present when you have image at infinity. If it is at d, then you know magnification will be f naught by fe 1 plus fe by d. Correct? Done. You have to also write the total summary of this three situation, overall summary of the magnification. You will write the thing. Near point, and the second is normal adjustment. Normal adjustment means at infinity. So first You have simple microscope. In case of simple microscope, if you calculate total, normal formula is magnification is equal to D by UE. D by UE is the normal magnification. If you calculate near point, then your magnification is equal to 1 by 1 plus D by FE. At infinity, this will be equal to D by FE. Okay? D by FE. By the way, in this situation, magnification inversely depend upon the focal length also. First, microscope done. Second is you have compound microscope. Compound microscope. So in case of compound microscope, you calculated different situation. Magnification was equal to magnification of objective lens and magnification of the eyepiece. Magnification is equal to D by U. So same, just application of the simple microscope. Your total magnification will be equal to V naught by U naught 1 plus D by FE. And here magnification V naught by U naught D by FE. Any doubt, guys? And last, astronomical telescope. You have common situation. Magnification is equal to F naught by UE. It's like first one, D by UE. Here you have F naught by UE. If you take near point, then your magnification will be equal to F naught by FE 1 plus FE by D. And at infinite, very easy, UE will be equal to FE, so F naught by FE. Done. And your all these things are done. Also, you have to use the length of the tube. Length of the tube in this case, L will be equal to F naught plus UE. And if you calculate here, length L is equal to, um, first your image was formed, so V naught plus UE. Ask me, guys, any doubt?
No, sir.
So write this. Anything we missed from the last point? No, because in refractive type of telescope, you don't have this formula type kind of thing. You have here only. Write this 3 times all together. You can also write here m naught is equal to v naught by u naught. Next time onward, you have to just see this summary for the need. About both the diagram are important. There is always 100% question from the compound or astronomical telescope, at least from one. Last year you got question, Chandana, Tuhina, Jordan, from microscope or telescope, 5 marker
Yes, sir. They asked us from telescope.
telescope.
Yes, sir.
One thing is common in the astronomical, like not astronomical, in general in the normal adjustment. In your normal adjustment, UE is equal to, here UE will be equal to FE. This is permanent. In first situation key, main formula is D by U. But for the infinity, it will be instead of UE, FE. So infinity is easy. Near point, normal adjustment, type of microscope. I'll show you a recent question of PYQ. It was so direct, straightforward. You will feel like, sir, how anybody can ask such a simple question. Before that, you also note down the question. By the way, you also get idea, na, ki if you are observing, let's take Mars. So in this situation, if you want to see bigger picture, magnification is bigger. Your focal length should be more for objective lens and very small focal length for the eyepiece. The smaller the eyepiece, better will be the magnification. Imagine, because sometimes they can ask theoretical question. If you want to see bigger picture of the planet, how you should adjust the focal length of eyepiece and objective length. Eyepiece it should be less, and focal length it should be more. Make it fast. Anvita and Sandana, you finish this question.
Ừ, nghe khẩu hả nghe khẩu biết chưa giờ hả
You finish this topic. So, you know, when you calculate solve this question, you can calculate magnification at infinite. Is pretty easy. Magnification at
Magnification is 4, sir, at infinite.
yes, 20 by 5.
25 centimeter, 4.8.
Yes. If you say length is the focal length plus Fe for the infinite. Remember, this will be 25 centimeter for infinite. And then if you calculate the magnification, Fe, F not by Fe, 1 plus Fe by D. This is equal to 4, 1 plus 5 by 25, 1 by 5.2. So 0.2 plus 1, 1.2. So 1.2 will be 4.8. So at infinite, image is 4 times bigger, but at near point, it is almost 5 times bigger. Last small micro telescope, which is not very popular for your NEET exam because there is no formula as such, but you never know what can be asked in your exam. That's why you have to be prepared well for this. This is the reflecting type. Astronomical was refracting. This is reflecting type or also known as Cassegrain telescope. In this telescope, we use improved version of astronomical telescope. This is better than astronomical telescope. Version of astronomical telescope. Why? Because here you have better resolution. There is no color issue and no focal length issue. That's why you will see overall better resolution. Better resolution means image quality is good. Resolution. Here you can eliminate chromatic aberration. Chromatic means color. Aberration means any abnormality. So color abnormality faced in the astronomical telescope can be eliminated by this method, or if focal length is changing, so you can eliminate the spherical aberration or focal aberration. Okay. If you see In case of astronomical telescope, size is very big, so difficult to handle. Here, this is handy. Small size, so you can easily manage this. But in astronomical telescope, you know, it is bigger in size, especially objective lens should be bigger and difficult to handle. Okay, and no doubt the cost, low cost in case of, because small size, for low cost in case of Cassegrain telescope, but high cost in case of this astronomical telescope. Okay, so what happened? Diagram is important. You take mirror this time. Like this. In this case, what you will see, outer side is the opaque. Inner side, whenever light will fall. Example, if any light enter here, it will enter like this or like this. This is how light is falling. Now, after this reflection, it will move like this. After reflection, it will move like this. And here you have another mirror like this. You have another mirror. What will happen in this case? All light will be focused at one point. See, your same image will be formed at one point, and this is your eyepiece. Here you have eyepiece where you contain the convex lens. Important. Other than that, you have objective mirror. This one where objective mirror where your light fall on. This will be known as objective mirror, which is concave in nature, which is concave in nature. And you have one more mirror, which is convex and also known as the secondary mirror. This is known as secondary mirror. And this secondary mirror is convex mirror. So Cassegrain telescope or reflecting type, as the name suggests, it is reflecting type, so it contains mirror. Two mirror, primary mirror or objective mirror is concave, and second mirror convex mirror. And at the end you have eyepiece, that is convex lens. And with this, you are done with the ray optics. Only one topic is left from the physics, that is wave optics. Tell me anything else we left from this physics portion. Send me your this notes. 3 times I gave to write